All right, gang, we got one last question to do for chapter 2. We're gonna try to put it all together and do one question that will combine all the kind of skills we've learned so far. So let's say we've got Ian, who's searching for buried treasure with a metal detector. He's going 94 meters, 46 degrees north of east, another 321 meters straight to the west, and then another 794 meters, 84 degrees north of west. We want to find his total displacement vector. In other words, the magnitude and direction of the resultant made. Oh my gosh, my straight lines are so bad. The magnitude and direction of the resultant vector made from adding all of these vectors together. So please, right now, pause the video, and let's go ahead and try to solve this, and then we are done with chapter 2. Okay, so let's take a look at this question here. We have Ian searching for buried treasure with a metal detector. He's going 94 meters, 46 degrees north of east, 321 meters straight to the west, then another 794 meters, 84 degrees north of west. Okay, so this is a question that I want to draw my coordinate system on for sure. Let's start with that. So here is my Cartesian coordinate plane. I'm going to label north, south, east, and west like this. I'm going to call north positive. I'm going to call east positive. I'm going to call west negative. I'm going to call south negative. Okay, so there are my signs. Now we are adding 3 vectors. I'm going to do this in 3 colors. So the first one, he's going 94 meters, 46 degrees north of east. So, okay, that means we've got a vector like this. This angle is 46 degrees, and this length is 94 meters. I'm going to name this vector 1. Then we have a second vector where he goes 321 meters straight to the west. Obviously, I'm not drawing this perfectly to scale. I'm going to kind of guesstimate. So if I made that 94, 321 is pretty long. Let's look over here. Kurt says, I cannot draw straight lines to save my life. It's okay. So this is going to be our vector number 2 here. And this is 321 meters straight to the north. Or straight to the west, excuse me. And then our third vector, I'll make this one green, is going to be 794 meters, 84 degrees north of west. Okay, so north of west is going to be north of where a straight line going west would be. So that means that it's kind of like this, where this angle is 84 degrees. And this amount here is 794 meters. I'm going to move my text box that's got the question in it, actually. Oop. I just select this. Let's go. Okay, whatever. I'll just draw this again. It's fine. Everything's fine. 794 meters. Okay, great. So now that is our 3 vectors, and we want to know the total length. So we're trying to find out the total vector between the beginning and the end like this. So what is our total distance? And what is this angle theta? All right, so step 1, whenever we have a diagonal line in physics, we're going to kill it on site with sine and cosine. So first things first, we're going to find out what all of our x and our y components are. So here I've got my first vector's x component, and here I've got my first vector's y component. We're going to find these using sine and cosine. So we're going to take cosine of 46 degrees, and we're going to take sine of 46 degrees. The side that is touching your angle gets the cosine, the other side gets the sine. So notice my x side is touching my angle, my y side is not. So sine 46 times 94 will give me my x angle, or my x length, excuse me, and sine 46 times 94 will give me my y component. Okay, so let's do that in a calculator right now. They're going to be close to the same. (46) times 94. I'm getting about 67.6 meters for my y. And I'm getting cosine of 46 times 94, 65.3 meters for my x component. And that makes sense. 46 is slightly more to the y direction than it is to the x, so I get them being close with slightly more to the y. Sounds good to me. Okay, our next vector, vector 2, its x and y components are actually quite easy. Notice this is a straight line purely to the west, and no part of this is moving north or south. So this thing's y component is 0. It is not, notice this line here is not moving either up or down. It is not moving in the y direction at all. So a straight line going in a cardinal direction actually is not going to have any component not in that direction, right? So 2y is going to be 0. Vector 2 x component, on the other hand, well, 321 straight to the west is just going to be negative 321 meters. Okay, why is it negative? It's moving in the direction that I named negative. I named this the negative direction. So because it is going to the left, it's negative. Likewise, my x and my y component for both of these are both positive for the first vector, for vector 1, because x is going to the right, y is going up. Notice if I trace this arrow, I'm going to the right and up. Okay, last vector, vector 3, the one in green. Let's figure this one out. So I have this angle here, or this line here, excuse me. This is going to be vector 3's x component. This line here is going to be vector 3's y component. Okay, so as always, we want to kill a diagonal line on site. So I can say vector 3's x component equals, and vector 3's y component equals. I'm going to kill these with sine and cosine. The side that touches the angle gets cosine. So remember, it's sine and cosine times the length of your vector for your x and your y component. The x side is the one touching this angle here. So I could say the cosine of 84 degrees times the whole length of the vector, which is 794, will give me my x component. And the sine of 84 degrees times 794, the whole length of my y component, will give me, sorry, the whole length of my vector will give me my y component. So let's go ahead and do that in a calculator really quick. The sine of 84 degrees is like 0.99 something, makes sense, times 794. So my y component is going to be 789.7 meters. And vector 3's x component is going to be pretty low. That is cosine of 84 degrees times 794, 83, thereabouts. Okay, now last thing we got to do is assign signs to these. My x component is going to the left, so it's negative. I'm just going to put a negative sign in front of that. So it's not 83, it's negative 83. My y component's going up, so it's positive. Cool. All right, so now I've got my 3 components of my 3 vectors, and that means I can find the components of my final vector here, the one that I drew in purple, the total that I want to find for the question. So I can say that the sum of my x components will give me my x component of my purples, which is going to be 65.3 plus negative 321 plus negative 83. And also the sum of my y components will equal the y component of my final vector, which is going to be positive 67.6 plus 0 from the second vector plus positive 789.7. Okay, so that will give me my finals. 65.3 plus negative 321 plus 83 is negative 338.7 meters. And that is my total distance of the x component. And then 67.6 plus 0 plus 789.7 is 1,465.7 meters. That is my total distance of y component. Perfect. Okay, now we are almost done. All we have left to do is make a right triangle out of our 2 components. So here's my total distance vector. Oh my God, that sucks. Let me try that again. That's a little better. Here is my x component. Here is my y component. My y component is 1465.7. My x component is negative 338.7. I would like to find this angle theta and this length d. Okay, so let's go ahead and try this out. We're going to use the Pythagorean theorem to find d first. You can do this in either order again. I will say a squared plus b squared equals c squared. C is going to be this side here. A and b can be either of the other two. That's 1465.7 squared plus negative 338.7 squared equals c squared. Oh, sorry. By the way, when you're doing, sorry, I should get rid of this negative sign. When you're drawing this as a right triangle, don't mind your negative signs. They just show you direction. When we're talking geometry, we can't have a negative side length. So you just call that 33.8. Although squaring it would get rid of the negative anyway in this case. It is technically correct to like make sure you're not putting a minus sign in for your math. All right, so 1465.7 square is really big. 2,148,276.5 plus 338.7 squared is 114,717.7. Add these together, 2148, 265, 276, I mean, 5 equals c squared. I get 2,262,994.2 equals c squared. Square root both sides of this, we can get c equals 1,504.3. Do a quick check, by the way, to make sure that your hypotenuse is bigger than both of your two sides. It is, we're good. You'll never get a hypotenuse that's smaller than either of your two sides in a right triangle. So you can double check to make sure you did this correctly by making sure that your C is bigger than both of your A and your B. So this distance over here is 1,504.3 meters. Okay, now, lastly, let's go ahead and try to find this angle theta. That's the last thing we got to do. And remember, theta is going to be equal to an inverse trig function of two of our sides. So we could say that that's equal to arc cosine of adjacent over hypotenuse, which is 338.7 over 1504.3. We could also say it's equal to arc sine of opposite over hypotenuse. That's 1465.7 over 1504.3. Or we could say that it's equal to arc tangent of 1465.7 over 338.7. Now, by the way, when you're doing this, make sure you've gotten rid of your negative numbers. Remember, now that we're dealing with geometry, the negative sign is just showing us direction. It's not showing us the actual side length. So make sure that you have this and this being positive. But anyway, any of these three functions will give you the same thing. I will go ahead and check my calculator to see which one is correct. So, or what the correct answer is, rather. All of them are correct. Do this. 1465, I mean. 65.7 divided by 1504.3 equals 0.97 something. And then let's take the arc sine of that, please. 76.9 degrees. Okay, so basically, if Ian walked this direction at that distance, then this direction at that distance, then this direction at that distance, the total distance he moved from the original point would have been equivalent to 1,504.3 meters at a 76.9 degree angle. Okay, so we are now done with chapter 2. Hope you guys learned something, and I hope you have a great time in lecture. See you later.